Hello, this is Domenico Composto, and we're going to illustrate another monopolistically competitive market structure. And before we do that, let's just go ahead and review the assumptions of the model. With monopolistic competition, we're assuming that there are a large number of firms, thus making the market structure competitive. And as a result of a large number of firms, each individual firm has a small share of the total market. And we're also assuming that each firm acts independently of the other. With these firms, they are offering a good or service, but it is slightly different from their competition, and that gives the firm the ability to determine price to a degree. So these firms are price makers, which gives them a downward sloping demand curve. So if they want to sell another unit, they can lower price and increase the quantity of demand. And because these firms face competition and because substitutes are available to consumers, the PED is greater than 1, so it's elastic. In terms of product differentiation, it could take the form of physical differences. One brand of car might be different from another manufacturing company's car. iPhones slightly different in their physical appearance from Samsung phones. There could be quality differences, low versus high quality, the location. Maybe one restaurant has more walk-in traffic because it's better located than another. In terms of the services offered, the product image, the strength of the brand, the advertising, the marketing, the celebrity sponsors, etc. And last, we assume no to low barriers to entry. So thus, it is fairly easy for an entrepreneur to enter this market structure. So let's go ahead and illustrate this second scenario. So again, we're going to be illustrating monopolistically. A competitive firm. This is going to be our second scenario. Scenario number 2. And in this scenario, we're going to assume that the firm is starting at a loss. And it will, a loss in the short run, and that for the surviving firms, they will gravitate towards normal profit. So that's what we're going to illustrate, going from a loss to normal profit. And we're going to take the example of the market for Turkish restaurants, the same example I used in the previous video. So we're looking at Turkish restaurants in a particular neighborhood. Okay, market for Turkish restaurants in a particular neighborhood. We're going to look at graph A and then graph B, looking at these individual Turkish restaurants. On the x-axis, we're measuring quantity. And on the y-axis, we're measuring price, costs, and revenue. And for graph B, the same. We're measuring price, costs, and revenue. Okay. So first, I always like to draw the supply curve first. So we have this backwards J shape according to the law of diminishing marginal returns, where S1 equals the marginal cost of production for these restaurants. And then we have the ATC curve, and it intersects with MC at its lowest point, ATC 1. And now I want to show this restaurant at a loss. Okay, so I'm going to have the demand curve significantly below the ATC. And it's going to be fairly elastic. Again, we're assuming that there's substitutes, that people have choice. They can choose a Japanese restaurant, a Mexican restaurant, a Greek restaurant, a Spanish restaurant, etc. So it's fairly elastic demand curve because consumers have substitutes. Demand equals average revenue, which is equal to marginal benefit. And we'll have the marginal revenue curve going into negative territory, MR1. So we're going to assume, again, profit maximization, that is the objective of the firm. And profit maximization occurs where the marginal revenue equals the marginal cost. So here is the marginal cost of production, and here is the marginal revenue, and they intersect right here. MC equals MR at this point, and that sets the quantity at Q1, and they will price according to their demand curve, and people are willing and able to pay this particular price at P1. Now here's a problem. To illustrate this, we see that at P1, which is our average revenue, at the quantity of Q1, they're pricing here, but their average total costs are right here. So the average total costs are right here. So we can label the cost of production, C1, which equals average total costs 1. So the firm is generating a loss. This blue rectangle reflects that this restaurant is not doing very well. How can that be? Well, in the long run, we know that all firms are at normal profit, but something happened. Let's use a relevant example. COVID, the lockdown, people in quarantine, people in self-isolation, people afraid to go out and consume, people a little bit nervous about going to restaurants. That's causing the demand curve for restaurants to decrease. So in graph A, demand has shifted in to the point where the restaurant is generating a loss, that their average total costs are greater than their average revenue. Now, this is happening worldwide. Many businesses are suffering due to the fall in demand for a variety of different goods and services that we consume, from retail to restaurants to bars, etc. So what can a firm do? Well, they're going to try to reduce their average total cost. They're going to try to bring ATC down. And one way that they can do that is to reduce their variable costs. So they're in the short run. Perhaps they are paying rent for their commercial space, so they can't move out. They don't want to move out just yet. So before they move out of a commercial space and potentially downsize or just exit, they're going to have to reduce their variable costs. And they're going to reduce their variable costs by firing labor, unfortunately. Labor may be fired, or maybe they will ask labor to work part-time as opposed to full-time. So restaurants are going to be desperately trying to reduce costs, and for most businesses, the biggest cost is labor. As they reduce their average variable costs, such as labor, it will pull the ATC down. Okay? It will pull the ATC downwards. Okay? And as they're able to pull the ATC down, they're trying to get the ATC to get towards break even. So if they can pull the ATC down towards their demand curve, where at least AR equals ATC, then they're breaking even and they are okay. So that's one thing that some of these firms are trying to do. They're trying to reduce their variable costs, which will pull ATC down so that they can at least break even. Or some firms, maybe they'll try to reduce their variable cost. It's not enough, and decide that that's it. We're going to have to shut down and exit the industry. Perhaps price has fallen to below minimum AVC, and they're going to have to shut down and exit. So that's another thing that could be happening. So firms that are generating a loss, some of those firms are going to reduce their average total costs to eventually go to normal profit, and other firms that are generating a loss where their price is below minimum AVC, or below AVC, I should say, are going to have to shut down and exit the industry. So in the long run, what we're going to see is this. In graph B, again, we have our supply curve, S1. We'll call this, I'll call that S1 equals marginal cost curve 1. And then we have our ATC curve. And then we have our demand curve. Okay, so the demand curve, we're going to have just sliding across the ATC curve. Demand equals AR1 equals marginal benefit 1. And then we'll have our marginal revenue curve going into the negative territory, MR1, assuming profit maximization, we're going to produce where MR equals MC, setting quantity here at Q, let's call this 2, Q2, so we don't confuse it with graph A. D2, AR2, MB2, MR2, and Q2. And that sets the price according to the demand curve here. We notice that price equals the costs of production because the firm is producing where AR equals ATC right here. Okay. So what's happening? So in graph A, firms try to reduce their ATC. If they're able to reduce their ATC curve by reducing their variable costs, in many cases by firing labor, as they pull ATC down, then they're in graph B. They've pulled ATC down so that they're at break even. In addition, you have some firms generating a loss where price is below AVC, so they're going to have to shut down and exit the industry. So what happens with firms that shut down and exit the industry? The firms that survive will see their demand curve actually increase. And as the demand curve actually increases, it will increase to normal profit. Okay, so there's two things that could be happening to bring a firm to normal profit. One, they reduce ATC and they're at normal profit. Or two, the firms that generate a loss, they shut down exit, which increases demand for the surviving firms. So let's go ahead and analyze this as we would on a paper 1. So as can be seen, we have two graphs illustrating a monopolistically competitive firm. We're looking at the market for a particular restaurant, perhaps it's a Turkish restaurant. And in graph A, and in graph B, we're measuring the quantity on the x-axis, price cost revenue on the y-axis. We have an upward sloping supply curve labeled S1, which is equal to our marginal cost curve 1. And it intersects with the ATC curve at its lowest point, ATC1. And we have two downward sloping revenue curves. The demand curve labeled D1, which equals AR1, which equals marginal benefit 1. And we have a marginal revenue curve labeled MR1. Now, please note that MR is less than AR because we're assuming that the firm does not price discriminate. So in graph A, assuming profit maximization, the firm will produce where MR equals MC, setting quantity at Q1, and they will price according to the demand curve, which is at P1, which is equal to AR1. And we notice that at Q1, the ATC is greater than the AR, that costs of production are greater than the price being charged. So the firm is generating a loss in the short run. What happens? The firm will try to reduce their variable costs. They might begin to fire one of their biggest variable costs being labor. As they reduce their variable costs or their average variable costs, it will bring the average total costs downwards until they reach their break-even price. Another scenario is firms that generate a loss might have a price below AVC, and they will shut down and exit the industry, and the surviving firms will experience an actual increase in demand. Either scenario, either reduction in ATC or an increase in demand as a result of firms shutting down and exiting and demand increasing for the surviving firms, will take us to graph B. And in graph B, we see that the firm again is producing at MR equals MC at quantity 2. And at quantity 2, they're producing at a price that's equal to their costs, or where AR equals ATC. So the firm is generating normal profit. Okay? So that is our analysis. What about some evaluative points? In your evaluation, you'll be discussing a few things, but two things that your evaluator will be looking for is your discussion about productive and allocative efficiency. So productive efficiency occurs at minimum ATC. Okay? And minimum ATC is right here. All right, there's minimum ATC. So if the firm's producing there, they're productively efficient. But we see that at Q1, ATC is greater than minimum ATC. So we can see that ATC1 is greater than minimum ATC. So since ATC1 is greater than minimum ATC, the firm is not productively efficient. It's productively inefficient. Inefficient. All right, and that's the case for both graphs, right? Here, ATC here is greater than minimum. So the monopolistic competitive firm is always productively inefficient. What about allocative efficiency? Let's use another color, maybe this purple. Allocative efficiency occurs where the marginal benefit equals the marginal cost. And when we look at the quantitative output at Q1, we see that the firm at this point, here's our marginal benefit, it's greater than the marginal cost. Here's our supply curve. Here's MC. So it is under allocating. Right? You can start to see that welfare loss, this purple triangle. So there's an under allocation of resources. So the monopolistic competitive firm is allocatively efficient because at Q1, marginal benefit is greater than marginal cost. And we see that in graph B as well. At Q2, the marginal benefit, right, which is right here, here's our marginal benefit, is greater than our marginal costs. At Q2, MB is greater than MC. And here you can see the welfare loss triangle, right, this purple triangle. So at Q2, again, marginal benefit is greater than marginal cost. So there's an under allocation of resources. So the monopolistic competitive firm is neither productively efficient and it is not allocatively efficient. And that's it. So we have graphed and we have analyzed this market structure and we've evaluated the productive and allocative inefficiencies of these firms. Thank you so much.